Okay. Hello. So myself, Dr. Suman Saha, Chemical Engineering Department, Tarul Institute of Technology. I welcome Dr. Geeta Kumari, Senior Scientist and in charge TCCT Division of Sardar Patel Renewable Energy Research Institute, Vallavidanagar, Anand, Gujarat. So, Dr. Geeta has completed her PhD with more than 10 journal publications from Indian Institute of Technology, Guwahati, in the year of 2019. Her field is related with the thermochemical conversion of various components. So I welcome Dr. Geeta Kumari to deliver her valuable speech for today's session. So Dr. Geeta Kumari. Uh,
Okay.
um, okay. Yes. Yes.
Am I audible now?
Yes, ma'am, you are
Hello?
audible. Hello, yes, you are audible.
Okay, thank you so much. Thank you so much, Dr. Saha. And I'm really sorry for the delay due to some technical error in, I think, from my side only. Okay, so here today I'll be discussing about thermochemical conversion technology. Let me briefly explain about myself, like Dr. Geeta, I'm working currently in Sardar Patel Renewable Energy Research Institute in the division of Thermochemical Conversion Technology. We have 4 divisions here. First one is solar, and second one is bioconversion technology division. Third one is thermochemical conversion, and the fourth one is technology transfer division. So here, actually, we are working on renewable energy only. So I'll go to the slides. Okay. Wait. My slides are visible.
Slide, the PPT is visible, but if you are changing that slide, then yes, now it is visible.
Okay. So I think I have very less time for this. Yes.
Hello. Yes.
Hello.
Yes, slide is visible.
So, sir, yes, sir. Visible, no? Okay.
Yes.
Okay. Okay. So, first, I would like to explain about biomass, biofuel, and bioenergy. So, biomass is nothing but a non-fossil material of biological origin, which includes crops, agricultural residue, or forestry waste. We can consider any kind of waste as a biomass. The average composition of biomass is actually, the biomass is basically comprised of cellulose, hemicellulose, and lignin. The percentage of cellulose is 40 to 50%. Hemicellulose is 20 to 25, 20 to 30%, and lignin is 20 to 25%. Again, what is biofuel? Biofuel is the fuel which is produced from biomass by direct or indirect methods, such as the example of biofuels are fuel wood, charcoal, bioethanol, biodiesel, biogas, or biohydrogen. The energy which is produced from biofuel is known as bioenergy, which is basically considered as a heat and electricity or transportation fuels. So what are the benefits of biomass? Biomass has several benefits. It is versatile, it has value for waste, it is abundant amount, and it has economical impact also. According to the survey, around 500 million metric tons per year biomass is generated in India, which has potential of 18,000 megawatt power generation. If we talk about Gujarat, then Gujarat contributes around 41.197 metric ton per year of biomass, which includes agro residues, forest residues, and wasteland residues, which is able for the production of 2,379.8 power production. Okay. So there are biomass conversion technology. There are basically two main type of biomass conversion technology, which constitute thermochemical conversion technology and biochemical technology. So bioconversion technology is basically fermentation and anaerobic digestion. I'll be talking about thermochemical conversion technology. So what is thermochemical technology? Thermochemical conversion technology. It is actually the it is actually the like thermo means heat and chemical means chemical transformation. So by applying heat, we transform the chemical which is present in the fossil fuels or biomass into energy and chemical product. So whenever the thermochemical conversion technology exists, then it's very simple. Like it happens in excess of air, or in reduced form of air, or in absence of air. So by all the three means the heat energy which is in the fossil fuel or biomass convert into useful chemical. Okay, so types of thermochemical conversion technology. There are basically four types of thermochemical conversion technology: combustion, pyrolysis, torrefaction, and gasification. So combustion happens more than 500 degrees Celsius, and the primary product of combustion is heat. Pyrolysis is it happens in the range of 350 to 800 degrees Celsius, and the major product of pyrolysis is char and bio oil. Torrefaction, it happens in the temperature range of 200 to 300 degrees Celsius, which the primary product is stabilized biomass, which is high rich in carbon. Gasification happens in the temperature range of 700 to 1500 degrees Celsius, and the primary product is syngas or producer gas. Okay, so one by one, I'll explain about all the technology. Combustion is a chemical process where any kind of fuel, which or fossil fuel or a biomass, react with air to produce heat energy. So here, the types of combustion. Basically, actually, the main type of combustion is complete and incomplete, but there are the subdivision also of the combustion. So complete combustion, the major product is CO2. Okay, and incomplete combustion, the major product is carbon monoxide. There is a partial oxidation reaction happens, which gives carbon monoxide. Rapid combustion, the example of rapid combustion is natural gas, LPG, petrol. Spontaneous combustion, which comes under phosphorus and sulfur. Explosion, the example of explosion is firecrackers and bombs. Okay, here previously I was talking about technology transfer division. Here, what we do, actually, we design and develop the reactors. We do the R&D on a bench scale, batch scale, pilot scale, and we transfer the technology to the field. So here we have in-house combustor, which has, this is the image of the in-house combustor, which is fuel flexible. That is, we can use any kind of fuel, wood blocks, briquettes, pellets. The hot air temperature is around 125 degrees Celsius. This is automatic fuel feeding. And the application of this combustor is for drying of agro produce, such as ginger, spinach, tomato, spices, etc. Okay, so pyrolysis. Pyrolysis is the thermal decomposition of material in inert atmosphere. This word like pyro means fire and lysis means separating. So by heat, the separation of there is a decomposition of the material happens, by which the chemical composition changes. So the product from pyrolysis is biochar, oil, and gaseous product, which is basically known as pyrogas, because this gas produced from pyrolysis process. That's why we called it pyro. Okay, this is the pyrolysis process. Actually, hello,
Hello, hello.
hello.
Yes, yes, yes.
Am I
Hello.
audible?
Yes, yes,
Okay.
yes. You are audible. Correct.
Okay. So what happened in pyrolysis process? The biomass first goes for drying and for moisture removal. Then we grind it for the desired size, and then we we inject it into the pyrolysis reactor with the help of screw conveyor. After that, the reaction happens. There in the bottom side of the reactor, there is a heater for the for applying of heat, which is actually needed for pyrolysis process. It goes to the cyclone separator, and from where we remove the char. There is two cyclone separator for high efficiency, and then after the gases, which is the condensable and non-condensable gases, the condensable gases goes to the condense, and the bioil which we extract from here, and the pyrogas which release to the atmosphere, or we can reutilize it for the recovery of heat. Okay, so type of pyrolysis, it it depends upon the product which you want. So there are two types of pyrolysis majorly: slow pyrolysis and fast pyrolysis. So in slow pyrolysis, the temperature range is around 400 degrees Celsius, and the product yield in slow pyrolysis is around biochar 48%, bioil is around 30%, gaseous product is around 30%. So here we have two reactor for slow pyrolysis. This is in-house batch scale pyrolysis system. We can see here that and the capacity of this reactor is 1 kg. And this is the salient features is on the right side, like biomass. This is biomass suitable for any agricultural or industrial biomass. The feed size for the particular reactor is 2 to 5 mm, which that is fuel flexible. We can use chopped feedstock, powder, or loose form. Temperature is around 100 to 650 degrees Celsius. Heating rate is 10 degrees Celsius per minute. And condenser type is water cooled double pipe. Okay, the product yield is mentioned here that biochar is around 27 to 38 weight%. Pyrolysis oil is around 18 to 22 weight%, and pyrogas is around 32 to 45 weight%. Okay, this is another continuous pyrolysis system which has capacity 18 to 20 kg per hour, which has heating rate around 10 to 25 degrees Celsius per minute. This is a continuous reactor. The inbuilt oil storage is around 40 liters, and which is flexible with wide range of biomass type. So, okay. So I told that the pyrolysis, the slow pyrolysis, basically used for the production of biochar. Okay, so what we do with that biochar? So here we convert that biochar into activated carbon. So there are two basic process for the conversion of that biochar into activated carbon: physical activation and chemical activation. So in physical activation, the precursor is first carbonized, then undergo activation using steam or CO2. In chemical activation, the biochar or precursor is impregnated with an activating reagent, any chemical reagent, like basically the most popular chemical reagents are S3PO4, QH, and ZnCl2, and heated under inert atmosphere. Okay, this is the schematic of the entire process. We can see here the feedstock is impregnated with activating agent. Then we dry it overnight. Then the pyrolysis process happens, and then we wash the activated carbon. And then again we dry. This is the final activated carbon. Okay, this is the experimental setup. Okay, the industrial application for activated carbon is like if the surface area of the activated carbon is greater than 500 meters square per gram, then that can be used for water purification. If it is greater than 600, that can be used for removal of heavy metals from aqueous solution or wastewater treatment. If it is greater than 800 degrees Celsius, 800 meters square per gram, then it can be used for air purification unit. Okay, the second form of pyrolysis is fast pyrolysis. This technique basically used for the production of bio oil. So here the bioil yield is around 60 to 70 weight%. Biochar is 10 to 15%, and the pyrogas is in the range of 15 to 30 weight%. This is the in-house fast pyrolysis reactor, which has capacity 10 kg per hour. This is a continuous reactor. So here the heating rate is 250 to 300 degrees Celsius per minute, and temperature range is around 100 to 100 degrees Celsius. This is basically for the bioil production. Okay. The industrial application of the bioil. Bioil can be used for production of chemicals, heat, and power. We have in-house bioil burner. This is the image of this. Okay. So third one is torrefaction. Torrefaction is nothing but mild pyrolysis, which is basically which has been explored for the pre-treatment of biomass to increase the heating value and hydrophobicity. Okay. So the best in this happens in the range of 200 to 300 degrees Celsius. The coffee beans are the best example of torrefaction. The typical mass and energy yield of torrefaction is around 70 to 80% and 80 to 90% respectively. Okay. The fourth thermochemical conversion technology is gasification. So gasification is a process which converts the organic matter present in fossil fuels into carbon monoxide, hydrogen, or carbon dioxide. So gasification conditions are like the temperature range is 800 to 1500 degrees Celsius. The product is basically depends upon what kind of gasification medium you are using. Okay, if you are using steam as a gasification medium, then you will get a higher amount of hydrogen. If you will use CO2 as a gasifying medium, you will get higher amount of carbon monoxide due to Bourdieu reaction. If you use air as a gasification medium, then the maximum amount of nitrogen will be in the product gases. Okay. So these are the chemical reactions which happens during gasification process. The first one is carbon will react with oxygen, and it will give carbon dioxide. The char will react with steam, and it will give the combination of carbon monoxide and hydrogen. There is a Bourdieu reaction in which the carbon will react with CO2, and it will give carbon monoxide. Again, this is carbon monoxide, which will react with steam, and it will give CO2 and H2. So these are the basic reaction during gasification. So this is the application of syngas, which is the mixture of carbon monoxide and hydrogen. We can see here there are a lot of application. We can use that syngas in boiler for steam and power production. We can use for the production of hydrogen. We can use it for the production of methanol, or we can directly use for Fischer-Tropsch synthesis process. Okay. These are the classification of gasifier. Basically, the gasifier is of two types: fixed bed gasifier and fluidized bed gasifier. So here, fixed bed gasifier has three categories: updraft gasifier, downdraft gasifier, cross-draft gasifier. And fluidized bed gasifier having two categories: circulating fluidized bed gasifier and bubbling bed fluidized gasifier. So this is the image of updraft, downdraft, and cross-draft gasifier, in which, okay, in gasification process, the all the three, like all the two process always happens. First one is pyrolysis, and second one is combustion. Because in gasification process we need char to react with the gasifying media directly. So here we can see here in updraft gasifier, why it is known as updraft gasifier. Here the syngas or the produced gases will exit from the upper portion of the gases. We can see from in this kind of arrangement, the biomass is feeded from the upside, and the air for gasification medium is injected from the lower side of the gasifier, and the final produced gases will exit from the upside. That's why it is known as updraft gasifier. Same with like downdraft gasifier. Here the produced gases will exit from the down portion of the gasifier. That's why it is known as downdraft gasifier. And in a cross draft gasifier, it is little bit, the arrangement is similar to downdraft gasifier. Here the gases will exit from the parallel side of the air injection portion. So this is the schematic of fluidized bed gasifier. Okay. We have in-house, this is a pilot scale fluidized bed gasifier, which has capacity around 20 to 35 kg per hour. In this arrangement, we use air as a gasifying medium, and the temperature range is 800 to 1100 degrees Celsius. The thermal efficiency of this gasifier is 65 to 70%, and carbon conversion efficiency is 88 to 92%. It has thermal output around 70,000 kilocalorie per hour. Again, we have another industrial scale fluidized bed gasifier, which has capacity around 80 to 100 kg per hour, and temperature range is around 800 degrees Celsius to 1100 degrees Celsius. In this also, we use a gasifying medium air, and the thermal output is 2 lakh kilocalorie per hour. The composition of the producer gas, which we get from this reactor, is around carbon monoxide 12 to 18 volume percent, H2 10 to 15, carbon dioxide 8 to 14, methane 3 to 5, oxygen 1 to 3%, and nitrogen 30 to 35%. So these are my team members which are working with me here in my division. Thank you. Hello.
Hello.
Hello. Sir.
Hello. Am I audible? Yes, yes.
Yes,
Thank
sir,
you
you
so
are
much,
audible.
Dr. Geeta. Yes, yes. Thank you so much, Dr. Geeta. Such a informative session we have just finished, and we like it's of knowledge about the different types of gasifier and the behavior of the thermochemical conversion procedure also. So students also, if you hello students, if you have any kind of queries, you are free to ask to madam related with the thermochemical conversion also. So if you have any type of query, feel free to ask me, or you can ask over here.
Hello.
Hello. Okay. Maybe they have received so many informations related with your presentation. So okay, I again will means like thank you, Dr. Geeta Kumari, for your valuable speech related with the thermochemical conversion procedure. So thank you so much,
Thank you
Dr.
so much,
Geeta.
sir. Thank you, sir. And
Yes.
and I'm really sorry
Thank you.
for the delay, actually.
Yes. That we understood regarding that network issue from your side. Or maybe it's very difficult whenever we will suffer from any kind of network issue. So again, no worry about that. We studied about
All
different
right.
types of procedure. Okay. Thank you so much, madam.
Okay. Thank you. Thank you. Have a great day, sir.
Yes. Okay. We are just concluding it. Thanks again from the PRW Institute of Technology and Engineering Department.
Hello.
Hello. Yes. Ma'am,
Can
you
you leave the
can
meeting?
disconnect
Hello.
that. Yes. Yeah, you can disconnect it.